All right. Can one of you record? You said you would. Yeah. All right. Awesome. Awesome. I need my phone for that. That's good. Okay. So, hi. We have -1 minutes before it's time to start. So, I apologize for these weird technical difficulties, but we had to like unplug the back of this to get an HDMI cable to work. I don't know, man. It's VGA apparently. But like, just look at what they like gave us to. Like, what? All right. Cool. So this talk is going to be recorded. It's actually recording right now. I'll probably edit out this first few minutes of me complaining about the HDMI adapter. So I would ask if you can hold your questions until the end, just because we're going to record it and it's going to be available online and all that. Come on in. Come on. So yeah, just hold the questions until the end. Alrighty. So let's get started. Hi. So who am I? Why should you listen to me? What's this about? So my name is Sam. I work for a company called SmartProcure. And one of the things that we do is we do real-time search and real-time analytics on around 1 billion documents from about 20,000 different data sources. It's pretty crazy. And the way we do this is to provide some pretty compelling search interfaces that are more than just search, where we give users everything they can possibly need to figure out our data set, because we do have a lot of it. So the talk here is called Building Data Exploration Interfaces, right? So what is that, right? What do I mean? Because I kind of just made those words up. I mean, they're all words, but I put them together. And they mean things separately, but not necessarily together. So a data exploration interface is something that helps users understand the data set that they're working with. So in the case of our data at SmartProcure, we have 1 billion records, right? And if you're trying to find something out, like how do you know where to even begin? So the biggest thing when building one of these interfaces that allow you to really understand a data set you're not familiar with is to make sure you always give users choices with context. So what do I mean by that? Well, imagine you're in a restaurant and you walk in and you sit down, the waiter comes up to you and says, "What do you want to eat?" Well, some of you might find that really cool, right? Anything, right? But a lot of people will be like, well, how do I know what to order if I don't know what's on the menu? So that's what this is about. It's about the menu, because as we all know, multiple choice questions are way easier than essay questions on tests. So why are we making our users answer essay questions? And that's sort of the false promise of the search box. You go to Google, it's easy, right? You type in anything and we'll find it. But if you don't know what there is to find, how do you know where to begin? Okay, so I've said some things here, right? And I'm talking very abstractly about interfaces that help users figure stuff out. But before we actually dive into anything, I want to just show some examples of what those are so you have an idea of what I'm really talking about. So let's dive in. So the first example, this is probably the holy grail. This is the most complicated thing, right? This is our advanced search interface. And don't worry if you can't read this, I'll walk you through really quick. But the idea is there's infinitely nested ands and ors and nots, and you can do pretty much anything with it. But along the way, at every point that we can, we try to give users a list of choices. So here there's this thing that says agency type, and there's a list view. And so even though it's in the middle of this and and or nested thing, we're showing you what are the agency types that are available, and what are the agency states that are available. Agencies are just organizations in our database. And so if you click one of these things, you would expect the other lists to update in real time to reflect the new, smaller data set that you're working with. And actually, if these were related via an or instead of an and, it would behave differently, because the set of choices would be different. So I wanted to start with this, even though this is probably the most crazy example, just so you get an idea of the kind of crazy stuff that we're talking about building. Because then from there, we just talk about our basic e-commerce style search, right? And this is our regular search interface. And this, again, these concepts are here where you've got faceted search on the left, right? You've got a list of choices. We're not just saying, hey, show me all the states that start with F, right? We're saying, well, what states are available? And not only that, but when you're telling me what states are available, tell me like how many results are in each one of them, so I have some idea of whether or not even that menu option, that list of things, is even something I'm interested in, because maybe I think that on the menu I'd like to order, the steak, but maybe only like 1 out of 1,000 people that come into the restaurant that day order the steak. Well, maybe it's not good. maybe I should see that everyone actually is ordering the chicken, and I should go for that instead. So that's what it's about. And then there's just some other examples of interfaces so you can see, nested aggregations. Even when we're giving people a choice of what fields to work with, we want to give them as much help as possible. Of course, that goes along with saying you want to show charts. You want to even do the dashboard approach where you say, like, here's a whole bunch of stuff all at once. You can go with crazy stuff that's in there. Crazy developer UIs for pivot tables. Even our internal admin tools, by the way, we try to follow the same approach. So hopefully you're noticing some commonality between these. The idea is interfaces that give additional information locally in each part to help you make the choices that you're trying to get through. So what we did is we built an ecosystem of tools to make building this kind of interface really easy. And so in this talk, I want to get you thinking about the kinds of ways that you can give users more information as they're building out their interfaces, and hopefully maybe even use our open source tools, because they are actually officially open sourced, and this is our kind of public debut of everyone go and try it and use it. And it's in production now, so it's, the first version of this stuff was built about half a decade ago, so it is battle tested and tried and true, and now it's open source for everyone to try. But before we get into the actual the actual idea of like, well, what is this library? And before we get into like, what are we offering? I want to just explain a bit about why, because, we're talking about these interfaces, but what kind of problems do you even have building them, right? So if you never even thought about an interface like that, what are you going to do? All right, so let's go on a little journey together, right? We're going to start off with a really simple interface, the simplest one you can imagine. Come on, let's go. We'll start off with the simplest interface you can imagine, and we'll make it progressively more complicated as it goes on. Now, I'm going to warn you, it will get a little hard to follow because that's the idea. I want to explain how all the things that you wire up, how it starts to get hard to keep track of all the different pieces and how they talk to each other. And then how this nice thing comes in and solves all the problems for us. So in the beginning, there's a search box, right? We already talked about why this isn't enough. But, in a normal search interface, you might do a search, and it'll come back, and there's movies. So we have an IMDb database. And yes, for those of you who may not have picked up on this, this is a live search. So if anybody would like to search for any other movies on IMDb, let me know. One caveat, we can't put a space in there because it is a slideshow, and if you press space, it goes to the next slide. So this is good, right? So we search for star, and then we got some results back. We told them a little bit of stuff. We're like, here's the movies, and here's some results, and, and that's great. And this is a pretty simple thing to design and build. So how would you build this? Well, you'd say, whenever the search box changes, I'm going to go run a search to get the results. Nothing out of the ordinary here, right? Well, you probably want to do this fancy thing we call debouncing, where we say, as you're typing, we don't want to run a search for S and ST and STA and STAR. We probably want to wait until it's been a little bit of time until you stopped typing things. But either way, it's still pretty straightforward, right? So right at the beginning, we've got a box. You listen to some changes. You kind of rate limit it so it doesn't go crazy and run a search. All right. Well, then you might add a number filter. So here we've got one for Metascore. What is Metascore? I have no idea. It's on IMDb. Probably something to do with the ratings. And so you can change it. And we can say, well, let's change this Metascore to like 70. And what happens? Well, the results filter down. This is, again, still hopefully pretty simple to design and follow, where, okay, when this changes, update this. And when this changes, update this. Also in this box. There's 3 boxes. Not a big deal. 3 boxes update. You go and get new results. And the whole time you're trying to make sure that you rate limit it so you don't go crazy. But then it starts to get a little more interesting because you want to start to do faceted search, right? This is the beginning of the contextual interface. We'd like to say, well, what genres are there? What actors are there? Now we've started to enter a little bit more complex of a situation, right? Because what's going to happen? Let's say you want to see only the comedies. Okay, well, apparently it's just this one. But what's happened? Well, when you click this checkbox over here, you got to update this, but not this. Sorry, update this and this, but not this. Why? Because if you click a new checkbox here, it doesn't mean the list of choices for that part of your search has changed, only everything else. Okay, so that's pretty straightforward. We can extend that and walk through what's happening. So if you update this, and you update this, or you update this, we're going to update this and this and this. If you update one of these guys, we're going to update this and this, but not this. And if you update one of these, we're going to update this and this, but not this. Okay, hopefully still not too hard. it's getting harder, right? Let's make it a little harder, right? Okay, well, what if we said that we wanted to give you the ability to search within those lists of results? So let's say, and forgive that little bug. I built this in like an hour. What did I say was drama? Oh, sorry. Okay. The joke came ahead. So if you wanted to search here and you want to say, show me just the, for example, things that matched, if that actually worked, what it's supposed to be. Well, now we have an even more complex case because we're saying if you update this and this, but not this. If you update this or this, it's the same thing. If you update this checkbox list, it's this and this, but not this. But now, if you update this, you only update this guy. There's no need to get new results. There's no need to get new actor options, simply because you've changed the list of genres that you're filtering it down further.
The checkbox may go away based on what is filtered.
Sure, yeah, that's probably the bug, is that it's probably hiding the results. But then it might get even more complex because you might decide to add a histogram, some charts. You might start to say, well, show me the releases and show me everything here that had star or whatever, and then show me by decade when was this released. Now, of course, we're down to one search result, so it's only one bar. But if we add a larger search, it'd show more things.
Increase the mask score.
Oh, you know what? That's smart. Bet you that's what it is. No, I think it's.
Put action instead of comedy.
Yeah, because comedy is checked. But, whatever, it's fine. All right, so anyway, the point is it got really complicated, right? And it feels like a game of operation. Because when you've got all these things, and well, when this updates, you update this guy, but not this one, it gets really complicated to manage. And it feels like a game of operation. So there's this great quote from The Simpsons. I don't even know if people still watch The Simpsons, but I'm assuming they do. And so Homer was having a triple bypass. He was all on the table. And it was a hilarious thing because the doctor is sitting there, singing that song that this bone's connected to that bone, and this thing's connected to this thing, and that's connected to the red thing. And that's connected to my wristwatch. Oh God, I've potentially murdered somebody, right? So that's not cool. But that's what it feels like because you're wiring all these things together, and you got to be careful that you don't run too many searches or too few searches. And by search, again, I just mean really any kind of results that come back. And so we also need to make sure, by the way, as we build a more advanced interface, that we have the ability to pause and resume these things. Like, for example, we only had results in a chart, but what if we had multiple tabs that showed all kinds of charts? Well, you don't want to get the results for the tabs that aren't visible, right? That would be wasteful. So really, it starts to get a little bit crazy, right? And by the way, in advanced search, even the types of those filters on the left can change. And we didn't even talk about what happens when they're nested ands and ors and how complicated it starts to get. Not to mention the fact that in the real world in these interfaces, you can dynamically add filters, which means you can't hard code this. You can't just say, I'm going to wire up the thing on the left to the thing on the right and the thing on the right to the thing on the left. You can't even do that because more things might show up dynamically. All right, so how could we fix this? Well, what if we defined some generic structures instead? So first, we combine these filters and aggregations into some kind of node. And can we also have these nodes filter, restrict the data set, but also have an easy way for them to provide local results without applying their own filters, right? Because remember, if you were to click an actor, you would not expect the list of actors to now include that filter, right? Because if I say, show me all the actors where the actor is Keanu Reeves, well, there's only one, because you said, show me all the actors where actor is in this list of one item. So on top of that, can we then implement different providers to abstract the details across the database? Because at the end of the day, you don't really want to be worrying about how to get the top values, right? Because your UI is just interested in, well, what are the choices? Not so much how do I actually run a search in Elasticsearch or MongoDB or any of those other things. And then, once we have this generic structure, can we then automate the updates with these reactors, where the idea is you just say this thing, when stuff changes, reacts in some way to update the rest of the nodes, or all of the nodes, or only its own node. And so what have we succeeded in doing? Well, if we do this, we'll have succeeded in abstracting queries and filters, results, aggregations into a tree. And that's really the main idea here, because by doing that, by abstracting them all into one, we can then start to leverage this generic structure to do interesting things, to do really cool stuff. We can automate those updates, make them really hyper-targeted to say that you no longer have to worry about the wiring. You just set it up in advance and say this thing, when these few things change, the rest of it's going to change. Or on this field, only this guy changes. We can do pausing and resuming, where we say, if you're not showing that part of your search and no one needs that information, well then don't run it. And we don't have to like explicitly code that. We can just say, well, when you go to another tab, we just call pause and now it's paused. We can even do really crazy stuff like cascading, where since we've kind of moved away from the idea of worrying about the database itself, and we just have these result sets, we can do cool things where we pipe the output of one of these searches, one of these little nodes, and make it the input of another node. So that's a little bit of a complicated thing, but that's really implementing something called a join, and it doesn't have anything to do with the databases involved. But don't worry, we'll get a little deeper on that. We can do all kinds of other stuff. But here's the thing. I just said a lot of stuff. I used a lot of words, and those words mean things. They mean things to me, but they may not mean things to you. There's a good chance I made up half those words. So let's make sure we all mean the same thing. So let's take a step back. Let's start with the anatomy of a search, because that's probably the first thing where people may be a little confused. So I use words like filters. Well, what's a filter? Filtering is where you take some data set, you've got a whole bunch of these things, and you say, I'm going to restrict that data set. So I'm not going to include this guy. So here's my data set. I'm filtering to just these three. Pretty straightforward. Queries are also pretty similar. They also restrict the data set, ignore this thing, but they also do some ranking, and they say, well, this one like kind of sort of matches. I don't know. So for our purposes, we're not going to care about that. We're going to abstract away the difference, and we're going to say these are just criteria. These are things that restrict your result set, maybe modify it in some way. What are results? They're just the things that came back, right? So in this case, if we filter down the data, the results here would be just these three nodes, or these three records. And aggregations are just crazy other things, where you say, show me the top 10 values in a set of stuff, like not the actual results themselves. But the idea is we're going to abstract all of this away. These are just the prerequisite concepts, so you should know what they are, but the idea is results and aggregations are just going to be contextual pieces of information, contexts. And filters and queries are just going to be the criteria. So I've also used some terms about Boolean logic, like and or and not. And there's a good chance you actually may not be following that, and that's totally reasonable. Because when I say I've got a nested search with ands and ors, it turns out humans are intuitively really terrible at Boolean logic. We think we're great at it, but we're not. And to give you an example, most people actually in English confuse and or directly. If you say, I want to see all the movies that have one guy as an actor and another guy, what you're actually saying is you want all the movies with one actor or the other actor. But people say and. So one of the things that helps is to use terms that are a little easier, like all and any and none. But the idea is even users don't necessarily get that, so you want to help them as much as you can. The other big thing I want to make sure everyone understands is trees. So what are trees? Well, trees are a data structure from computer science. And by the way, this is how we represent all of this together. In fact, actually, one last thing about the ands and ors. I'm sorry. The other thing that's really important is parentheses, the order of operations. Because if you say I want this and this or this, depending upon where your parentheses are, that could mean a very different thing. For example, if you're telling someone to go pick up lunch for you, and you go to Wendy's and you tell them, get me a hamburger and french fries or onion rings. Well, depending on where your parentheses are, they could come back with just onion rings, because they'd be like, well, they didn't have hamburgers, so, I mean, if they didn't have french fries, so I just got you onion rings. You're like, where's my hamburger? Like, where's the parentheses, right? So we want to make that super clear. So that leads into the next thing. We represent this as a tree. So a tree is a structure from computer science, data structure. And it's basically just a hierarchy. The idea is you have things, and those things have things inside of them. And those things can in turn have things inside of things. And you can go all the way down, as deep as you want. And that's really what it is. So trees have a few things that are important to us. We're not going to go super deep in all the computer science, but I'm going to use some words I just want to make sure you're familiar with. So trees have nodes. I've already used this term a few times, but when I say a node, I just mean one of these things. So in this tree here, this guy has these two as children, and this guy has these two as children, and this one has these two as children. So the nodes represent the things in the tree. Trees can have a root, which is this guy at the top, just the beginning of the tree. And trees have leaves, just like in the real world. And what are tree leaves? Tree leaves are the things in the end. The other important thing you do with trees is you can walk the tree. And what does that mean? It means you traverse. It means you start at one node and you visit all the other ones in some order. Now, in computer science, there's all kinds of types of traversals. There's depth-first traversal and breadth-first. We're not going to worry about any of that. The only one that we care about is specifically bubble up. Bubble up may not be the real term. I think I made it up. But what it means is you start at a leaf node and walk your way bubbling up to the root. So leaf is important, root is important. The idea is you go from the bottom and walk your way up visiting to the top. And by the way, if you're going to use any of our tools, you don't actually have to worry about it if you don't know how to actually walk a tree. There's this really cool library we use. It's called futil-js, the little logo here in the bottom. Those guys are doing an amazing job. And it's actually the only library, if you go to Lodash's website, which the previous speaker spoke about, basically the standard JavaScript library at this point. If you go to Lodash's homepage, you scroll down, it's the only other tool mentioned that isn't a Lodash thing. So it's pretty cool. It's all kinds of functional utilities, manipulating trees, just async utilities, all kinds of cool stuff. And a small spoiler, we do have one or two of the maintainers of that in this room. So, all right. So the last thing is data services. And hopefully this is not new, but I just want to make sure everyone knows, like, databases are a thing. There's different types. There's like relational, non-relational. It doesn't really matter. At the end of the day, we're talking about places where data live, and you can do something with an API, some kind of call, to go get data out. And you can interact with it in different ways by restricting the data set or performing some computations. So Elasticsearch provides this, MongoDB, SQL Server, tons of them. But they're things. So just to make sure everyone's totally on the same page, those are important. And usually each of these data services will have pieces inside of them. For example, in MongoDB, we have these things called collections, which is inside the database where you put related similar things of data, things that kind of share a schema, like that have a similar layout and structure. In SQL, we have tables. In Elasticsearch, we have indices. So all of these data services, the important thing is they have some way that you can say, I'm working with some schema, some structure of data where there's a bunch of them, and I can interact with it by restricting it and get more of it and perform some computations. And those are just things that are off the shelf and you can use them. Okay, so now you understand why we went into this, right? We started this because we wanted to just build some really cool UIs that give you contextual information, but it turns out it's really hard to keep it all up to date. And now you hopefully know enough about the background about, you know, what trees are and you know what ands and ors are and you know this kind of stuff. So now we have a new perspective. So let's get it at a new angle. So let's start by looking at the DSL for the server. So what we've created is basically a JSON DSL. So last talk spoke about JSON. And the idea is we represent the tree in JavaScript object notation where we have groups, which are basically just, groups are the non-leaf nodes. Inside of that, they have children, which could be groups themselves, or could just be leaf nodes. And so we give it some unique identifier so it's easy to access. We give it the type that this is not a specific type, it's a group. The schema is just saying which part of a data service is it talking to. And this is up to the implementation to decide where it goes. But the idea is you're just saying if this interacts with, for example, IMDb, right? It interacts with movies or interacts with, you know, food items on a restaurant menu. We have the join property, which is an and or an or not, which goes back to the Boolean stuff, right? So the idea is you have this structure, and everything inside of here is either anded together or together. It kind of acts like parentheses. And in here, those of you who are astute may recognize that this is the word join. Well, there is another one called in, which we'll get to later. But we don't have to worry about that right now. And then on the leaf nodes, you have a very similar structure. The only difference is really it doesn't have children. And we've got some custom type stuff. And this is really where the magic is. You define these little pieces that tell the tree how to restrict the data set. You talk about how to filter, and at the same time, how to provide some contextual feedback. For example, you might have a type that is a facet or checkbox list. So you might have a list of values, which is what the user's checked, and your context would be things like, well, what are the list of choices, and how many records match those choices? In the case of a number range, you might have a min and a max, or same with a date range, maybe a min and a max there as well. You might have just regular results, which would just show you the records that match, which is just, the context is just an array of things that came back. And so for those of you who are familiar with GraphQL, this is actually kind of similar, right? It's what GraphQL would be if it was built as a JSON DSL and not some crazy custom thing, so anyone can use it. If it was based off aggregations and filters first, and also if it was a tree. So GraphQL has a way to do kind of like a subset of this, but you can almost think of this as a more generic approach to extracting data than just something like GraphQL. Alrighty, so, and here's an example of a whole tree. And by the way, this is the actual tree that powered the search you guys saw previously. So we've got a root. Remember, a root is the beginning of a tree. The schema is IMDb, which tells it go get movies and stuff. And then there's children's. There's the search query, which is where we type the word star. We've got for genre we picked sci-fi, and we said Metascore between 0 and 100, and get some results with 6 of them at a time. And so this is it. This is all you really have to do. And then you just use the tools, and everything kind of just comes together after that. So the main idea here is building something where you take all of the logic around calculating stuff and figuring out like what all the results are, put it into one thing, and have a service that does it for you. So the next part is, all right, well then, great. So I've got one thing that will go and get all the results for me. How do I then intelligently say only part of the tree updates, which is really why we set off to start this. So that's where the client comes in. So the idea of the client is that you have actions that dispatch events to reactors. And so if you're familiar with Redux, it's really similar. So the idea is that you say, I'm performing an action like I'm checking a box. You then dispatch that action, which was, say, a mutate action to mutate the value. You dispatch it to the tree. It then has a reactor that says, OK, if you mutate the values, I see that for this type, this reactor is an others reactor. So we go through the tree. We start at the bottom. We bubble up. We visit all the nodes. We mark the ones that need update for needing update, and ones that don't, we say we don't need update. So let's actually walk through that. So an others reactor, you might start at the base. You might start at a leaf node, and you say, I'm dispatching mutate on values for the checkbox list, which means there's an others reactor. So when this comes here, we're going to first look at it and say, OK, well, others. So in this little group here, others means we should update this guy, but not this one. So we come back up and we say, all right, so this one's red and this one's green, which means this guy's going to get an update, but this one isn't. Now we're coming up here. Well, others in this set is going to be this, and so all of his children, and not this one. So we come up and we say, great. So we don't update this one, but we do update these. And then lastly, it's just a node by itself, so there's no need to update that one. A self-reactor is pretty much the same thing, but exactly opposite, where we say we start at this node. We say, well, this guy's going to update, which means this one won't. When we come up here, it means this is going to update, which means these guys won't. And then up here, we say this guy needs to update too. And that's really it. That's the interesting thing here, where if we can have a generic structure that allows us to get this entire tree at once, we can mark certain pieces of it to need update and certain pieces that don't. There are other kinds of reactors besides self and others, by the way. There is, of course, I mentioned pausing and resuming. So if one of these nodes was paused, then we wouldn't have to update. We just mark it and say, well, when it comes to be resumed, we'll update it then. And so there's all kinds of cool stuff. You can just look at our GitHub repo and see all the things that it enables. But let's actually see how it works. So it's still kind of abstract, right? We've talked about the theory, like what's going on, how does it work? Well, to use it is also pretty easy. So you start off by setting up your service. And by the way, this is all on GitHub. I don't expect you to read this or understand this. It's just to show you there's very little code. This is actually the actual source code for the talk. So you can see that's just setting up a way to talk to Elasticsearch. We've got something over here that's just going to set up the client, which is saying, here's how we set up this tree manager thing, which is really just requiring some stuff in and some configuration. And then here's the actual usage, where this is just a React application. We've got a tree wrapped in Contexture, which is pretty much the same blob that you guys saw a minute ago. We have a React component to render those IMDb cards. So it's just a flex box with an image tag, and flex is just a component that's display flex, that's all. And then these sort of generic components that we just required in, which are the query and range and some other stuff. So the whole UI there is just, there's a div and there's a query thing on the top. That was a box. Then we have a flex box. We've got, on the right-hand side of it, we've got Metascore with a range. We've got genre with a facet. And then on the right-hand side, so Flex 4, we've got result count and IMDb cards, and that was literally the whole thing. And that powers a search you guys saw that talks to an Elasticsearch index.
Can you zoom in so we can see?
That's a
more
great
how we
question.
created-
Oh, hey, look at that, I can.
The one before that too.
Yeah, I want to see how we can create it.
So my slides are not designed to go backwards. I'm sorry for all the... That's the next talk. I'll figure out how to go backwards. You can read that, right? Oh, well, so the idea is pretty much you're just instantiating a client. There's even more noise here. The reason why it's actually be less noisy in production is just that this is like version 1.0 of the talks. I'm sorry, of the stuff for the talk. So some of the things in here that are being set up, like how to snapshot and how to like extend stuff, you wouldn't even normally need that. It's just because I'm using MobX, and we didn't have a first-class story for using React and MobX until like I don't know, an hour into writing this talk. So it's all pretty easy stuff though. It's just you have a tree, it manages it for you. You just pass it into the client, and then you just call the API to dispatch actions to it. And if that's too hard, we have like React components. So you just throw them on the page. You just be like, give me a box and give me some checkboxes and give me some other things. And in like 20 lines of code, you can have an interface like what I just showed you. A little bit more, you can have something more complex. Oh, and I gotta zoom out. There we go. And then the main magic of like how do you extend this is how you build custom types. And this is probably filling in the missing gap for some of you, which is on the server, you implement these types with a filter function and a result function. That's type specific. So you might say like the number range just does a min and a max, like just some value. So you might have a less than character in Mongo, or a range filter in Elasticsearch. For the checkbox list, you might do a $in in Mongo, or a select in, or whatever. And then you might do a terms aggregation, or just like a group by to get the values. So you just build these things separately, tiny little pieces, and you can enable interesting features. Like, for example, a range filter, where you say there's a min and a max, and keeping in with the spirit of what we're trying to do, well, what are the min and max values? So we can show you in the context what's the minimum and maximum value. We can actually take that further and show you a histogram of the distribution of values. So how many movies came between, Metascore 20 and 30, and then all the way across to 30 and 40, and stretch it out as far as you want. In fact, we can do even cooler stuff where we can use statistical analysis, and this will get a little mathy, but I'm excited because this is the latest thing we just added. You can click a zoom in button. We'll go all the way to the edges. We'll look and see how many outliers there are. Like, so if something seems really far out, we can just automatically zoom in for you. We can do really interesting stuff because we're building a little local part of an application that does filtering and results and that kind of stuff. So once you've understood these things, we can do even more cool things. For example, we can do global debouncing. So I mentioned before, if you have that text box, you're going to want to like wait maybe half a second or something before you run a search. Same thing with all the different pieces. So instead of manually worrying about wiring stuff up or seeing how long you need to wait before those connections get fired, we can globally say, hey, just don't update anything if it hasn't been at least 250 milliseconds or half a second. We can do some really interesting stuff where we drop intermediate results, and these kinds of features kind of get more advanced, and so I wouldn't worry about understanding all the things it does, except that it makes it really fast. So for example, if there's a bunch of changes queued up, and 3 or 4 of them went, and like they came back out of order, like we just take care of that for you. It doesn't matter, and your search service can take 3 minutes or 20 seconds, and we'll still figure it out. We automatically give you state management on all these things, where we'll tell you like, is this node updating? So you want to show a loading spinner? Well, okay, you could try to find a way to like manually track when you did a search and then update a thing to update. It's the same problem, right? How do you know if some piece is currently updating, or if it's paused, or if it's never updated? So we give you all that stuff free. We've got a whole bunch of really neat example types, like the checkbox list and the number types and all those things. And then the last thing really that's most compelling is probably cascading. So once you've abstracted all this, you have some way where you can just give it a tree and get some results. We can then say, let's take the outputs of one of those results, pipe it and make it the input of another. So we can fire an event when this is done and dispatch it into a different tree. When you do that, what we're doing is we're saying, for example, let's say you have, in the IMDb example, you've got a list of movies and there's actors on them. And in a totally separate database, you have a list of actors and like their salaries. So you might say, show me all of the movies that have actors that made over a certain amount of money. Well, if they're not in the same database, you can't normally run that kind of query. But if you just say, we do a search and find all the actors where salary is greater than some dollar amount, and those actor lists come back, and we take that and dispatch it right into another tree, we can then actually do a join. Now, what's interesting is that because this is happening in the tree DSL, it's happening in this library, it's not happening in the database. It means it's not tied to a database. So what does that mean? It means what we've enabled is cross-database joins on non-relational data, which is actually a really big deal because normally if you have a database like Mongo or Elasticsearch, you're not used to being able to do these kinds of queries. Now, of course, this runs currently client-side in the browser, so you don't want to push it too hard, but it works. And that's something that's kind of novel and new that not a lot of people have ever really done before. And of course, going into that, we can add providers for all kinds of things. We have one in production now for Elasticsearch. We have one in production for MongoDB. We have a super terrible one for SQL Server that is not released because it's so terrible. But the idea is that because it's open source, everyone can start to contribute new providers and new example types. And suddenly we can, in fact, they don't even have to be databases. They can be web services. If they expose some API, for example, your CRM or your billing system, and maybe you don't have access to the database, but they give you an API, build a Contexture provider for it. And then join across all these database boundaries. And it doesn't matter what's inside of them. They could be relational, they could be document databases, they could be whatever, and we'll make it all happen. And hopefully you guys will help. All right, so this is where I just threw this on here because I figured it was important, but we're not going to go over it. The algorithms for this stuff are documented in Markdown, and you should go to our GitHub links and read them there. Not here. Oh, that sucks. Sorry, give me 1 second. So to recap, I shouldn't have actually clicked it. That's great.
What tool is that?
So this is all written in React.
Even that interface.
The whole thing, yeah. It's pretty cool. And the source code for this will be online too. So, you know, if you want to build some fancy presentations like this. Huh?
What's the GitHub account?
So everything is under Contexture. The links are actually at the end. We're trying to get back there. Sorry. Next time I'm gonna implement like a skip to. That'd be cool.
What's the license?
It's all MIT. Everything is as permissive as we can possibly make it. Okay, so here we go. So this was the server algorithm. You should go to GitHub, see it there. Don't click it while you're giving a talk, by the way, just pro tip. Client algorithm, again, it's really just to show that if you guys want to know how the implementation works, not only is the source code available, but we actually did some serious work documenting it. And at the end of the day, all of this stuff is just traversing trees. The idea is like, you have a tree. How does the server work? Well, you traverse the tree. You say for each one of them, run that filter function. So you stamp the local filters for each one of them. Then you run the results by then saying for each node in the tree, get all the relevant filters and combine them. And then just run the searches and put them back and stamp them on and return the tree. The client, similar. You go ahead and take the events as they get dispatched. You start at the bottom, and you visit each node along the way, sort of bubble up. And you set a whole bunch of properties and do some things, but ultimately you just go and get the tree, and it comes back. And if it weren't for tree traversals, this would be just like a for loop. So, or hopefully not a for loop, hopefully like a map or a reduce or whatever, but it's a whole other discussion. So the last thing I wanted to talk about was the roadmap, because this is cool stuff, but there's more cool stuff, right? There's always more cool stuff. So what's coming next? Because this is an actively developed open source project. It actually powers our entire business. So we're working on this every single day. That's not like this is something that is out there and 6 months go by and someone opens up a GitHub issue and then 3 months later someone replies. This is an everyday thing, right? So what's coming next? Well, we're going to build out our example types a little bit more. So we want to build as many as we can, checkbox lists and charts and all kinds of things that you can just, in your applications, drop them in. We also want to make sure that we take that join thing that I talked about, that in thing, move it into the server. So that's coming soon, where right now the join property was and or not. In is coming very soon, and that'll happen on the server side, so it's a little more efficient. And then other kinds of joins too. We're considering maybe doing some like data input stuff, because this is all about how to extract data. But to really build a full application that lets you explore data, you probably want a way to put data in. So at our company, we also have this like generic autoform thing where you can just describe the structure of a thing, and it'll give you an interface to edit it. So combining that with something like this means you could pretty quickly throw together an application that lets people enter data, modify it, and do really compelling search to explore it and see what they just put into your system. The other thing is there's a tool called Kibana. And some of you may be familiar with it, some of you may not. But Kibana is sort of like the interface for Elasticsearch. Elasticsearch is a full-text database, or search engine really, and it's pretty cool. And Kibana does this cool thing where you can just give it a URL, and it goes and looks at your Elasticsearch cluster setup, and then just lets you do stuff with it. So Kibana is actually a really good target for us because their source code doesn't use these concepts yet, and they're interested. We've talked to them a few times, and a nice, cool next step would be for Kibana themselves to start using this technology inside of it, but then taking it further, because remember, we're not tied to Elasticsearch. Kibana is an Elasticsearch tool, but if we build something where we go ahead and say, just give us the URLs for your database, and we'll ask the database what's inside of it, and then give you a cool UI, eventually you get to a point where you just say, here's my database, just give me a search interface for it. And so that'd be pretty cool. And then lastly, our crazy advanced search UI is also open source. It's super developer-y and under construction, but I mean, it does work. And you can add filters and stuff. You can add ands and ors, all kinds of crazy stuff. You can delete filters. This is coming soon. So as you can see, this is super developer-y, but it will soon be not developer-y. All right, and here's some links, and I'll post these all online, but really the word you want to know is contexture. Contexture is actually an English word. It's the fabric of things woven together, which seemed like a good word. It's like a super old word from a long time ago. And if you just Google these things, you'll find them. And also futil is pretty cool. So just to tell you what these are, by the way, Contexture is the server. The client is the thing that manages the tree. Elasticsearch is what makes it talk to Elasticsearch. Mongo is what makes it talks to Mongo. The React thing is what gives you React components. IMDb is an example talking to IMDb, and then the talk is this talk. And futil is that functional utility library officially mentioned on the Lodash homepage. So, all right, thank you. All right, so questions, comments, or snide remarks, all welcome. I think I saw you go first, yeah.
Did you say the product currently doesn't support any SQL servers?
So
MySQL,
it does not, but it's pretty easy to do. And that's one of those things that we're hoping by open sourcing this, we'll see that maybe there's some demand for it. So at SmartProcure, we do actually have some data in a SQL server, but we put it into Elasticsearch to do searching. Because the thing is, SQL full-text search is a really bad idea. It's not performant, whereas something like Elasticsearch, which uses a product called Lucene underneath the covers, that's an inverted index. That's a data structure specifically designed to do searching, whereas SQL not so much. So in practice, we haven't found it to be helpful, but anybody in the open source community is welcome to implement it. We're happy to help as much as we can, and maybe even support it ourselves too. So, yeah. But if you open up an issue, by the way, and like enough people upvote it, we'll just do it. It's fine. We could probably use it too. Very cool. Well, you should open up an issue. Right,
So
yeah.
the summary for this talk, you mentioned ranking specifically. I'm very interested in ranking visualizations. And wondered if you had any that you mentioned it briefly, but I didn't see anything.
Sure. So when it comes to ranking, I guess what I meant by that, it's like ranked choices. Mm-hmm. So when we showed the checkbox lists, they were actually sorted in order of the frequency that those values occurred in the data set. It's a little bit of a mouthful. So what I mean is, if you say, show me the list of, let's say, genres in IMDb, we're going to say, well, for each genre, don't just show me the top 10 genres. For each one of them, tell me how many movies are in that genre. And then if there's 10,000 genres and we're only going to show you the first 12, well, we're showing you the top 12 most relevant ones. results.
So you're sorting by count descending.
That one sorts by count. In terms of results, we can also do, which is implemented by things like Elasticsearch, querying allows us to sort by relevance. And so depending upon how close you are to your search terms, we can do all that stuff. But the key is, with all of this, is to offload all of that complexity to the databases that are highly specialized for doing this. And what this toolset is about is opening up the doors to those things and making them more accessible. Because you can build an example type, or a non-example type, whatever, a real type, for your application that may know how to talk to Elasticsearch and provide some new kind of visualization or a new kind of data that no one's ever really been able to get out before, and throw it right in the middle of an application talking to other databases that have never seen that before. So hopefully that answers your question. Alrighty. Anybody else? Questions?
So, is there anything else that it can be compared to what we're doing here?
Yeah, so I think there's some tools that have a similar intention. For example, if you're trying to build an interface for Elasticsearch specifically, there's tools like SearchKit, which is just React components that talk to Elasticsearch. Or if you're trying to search on Algolia, Algolia has UIKit, and they have their little helper thing for talking to Algolia. But the fatal flaw that all of these systems make is that they're all super tied to the actual database that they're searching against. And so this allows you to write code that can work with any of them and build reusable interface components, and also really carefully manage how the updates go about happening. And that's on the client. On the server side, this is really kind of a lot like GraphQL, but just a bit more powerful. Because GraphQL is really just about results. And you can have each of the individual pieces. You can have like aggregations and joins that you implement on your side related to properties. But GraphQL doesn't have like a native concept of, for example, within your query, part of them get different results and other parts get other things. This is really kind of like a much more abstract, more powerful version of something like GraphQL. So it's a good question, though. I think I saw one over here. What's up?
Yeah, I was wondering, let's say your results set is already large, so you're not going to display all the results. And then you start applying your filters, comedy, whatever else. Would you figure to rerun your query because now you pick up the ones you skipped before?
So that's the idea here. We deal with data sets that are pretty big. We have 1 billion records, 20,000 data sources, which, by the way, I forget how many. It's like 1 or 2 orders of magnitude bigger than all of Wikipedia combined. So it's pretty huge. There's no way that anyone can just sit there and like go next, 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 next on all of our records. It would actually probably take us down because that would be way too much data. So when you update the filters or the things on the left or in the middle or wherever your interface is, right? Because you can also like zoom in on a chart and like highlight it. It doesn't have to be a filtering interface. That's just sort of the simplest thing people have probably seen before, like an e-commerce style search. Every time you update stuff, you do need to get new results, but that's why this manages the tree for you, because it'll make sure it does it as minimally as absolutely possible. So that if you click 9 checkboxes in a row, we don't go get 9 searches. We wait until it's settled. If you go checkbox, checkbox, number range, new value in this thing on the top, instead of you manually wiring it up or figuring out how to optimize it so that you wait enough time, it'll just take care of it for you. So let your users do whatever they want. Have at it, click things, keep going, and then we'll just say, okay, well, we're gonna wait for you to calm down. All right, cool. Now we'll go get all your results and bring them back. So does that answer your question?
Yeah, so it has the smarts to know that it skipped a bunch of results, but it will go back and redo the search.
Right, exactly. Very cool. What's up?
When does it clear out what's sitting on the client's side? When does it know when to that this is not fresh or this isn't relevant to what we're searching for right now? Let's kind of free up some of that space so we can grab some more of this part of the tree.
Sure. So that's handled when new results come back. And the idea is
every time new results come back, it clears out
the previous stuff, right? Because we don't need it anymore. So the core actually is very hyper-focused on those kinds of optimizations that most developers would just ignore, right? They'd be like, I've got some data, I'll just have a memory leak and it'd be fine. That's not okay when you have like 1 billion records, because if you have a memory leak there, that's the guy's computer's fried, and then you get a weird support phone call about why your website made like Microsoft Word not work, and you're like, what? It's because they didn't close the tab, right? But that's a real story. So we're really, really careful to make sure that whenever we get new results, there's no reason to keep around the old stuff. In fact, the fundamental idea of this is making sure that we get the results as frequently as needed to, but as infrequently as possible. And when you get new results, there's no reason to keep the old ones around.
How granular is the configuration for the developer? Yeah, if I want to set my delay to 5 seconds after the last click.
Yep, there's a global
3
debounce.
seconds.
It's as many milliseconds as you want. I think we, in our actual application, put it around 500 milliseconds just because searches can get pretty heavy. You can do it at 250, you can do it at 1. In fact, all of our unit tests set it to 0, so we can run it faster. But yeah, it's completely configurable. And even for each one of the types, you can decide and define if a certain event type requires other things to update or just some part of it. You actually expose a lot of control. At the same time, we try to also have ready-made components so you don't have to deal with that if you don't want to, and just trust that it's going to work and it's going to be great and it's going to be efficient. But if you're like, is it though? Then you can kind of look in and see.
Yeah, there were things similar to this before, like Breeze.js that I've used before, things like that, where I'm able to hook into Mongo or SQL or whatever as the back end. This is pretty much what you're doing too.
So Breeze is interesting because Breeze is about modifying data and retrieving data.
Yes.
What Breeze doesn't do, which is the same thing that nothing does besides something like, at least I haven't seen besides something like this, is to really take care of wiring up the things together on the client. To say that even with Breeze, you might say, I've got this checkbox list and I've got this result set and I've got all these things going on. Well, when this thing changes, you're still gonna have to know, you still have to hook it up and say, well, okay, when this changes, make a Breeze call and then tie all the things together.
Right, yes, I do have to do that when I'm
Right.
to predetermine that, okay, if this is going to happen, I have to predetermine rewire that.
Yep, and so this is
Yours
all about.
goes on the fly.
Yep, this is all about not having to think about that as a developer, to just think more abstractly in terms of these are things that, because this affects the rest of the data set, I know I'm going to just update the rest of the tree.
Breeze creates containers for each of these polls, each of these that pulled up. And you can join between each one of these sets, and yours does it without me even having to think about it.
That's the idea, yeah.
Slick, I like that.
Very cool.
Easy's fun.
Yeah. What's up?
So, how does it compare to Movex?
Okay, so that's a good question. So there's a few parts to this. There's the client and the server, which are really different things. The server is what runs the tree. The client is what manages the tree. So Movex state tree, in particular, is about managing state related to things like serialization and updates, whereas the client here is really about reactors. In fact, to think about it in terms of Redux terms, which is a good, if you're asking about Movex state tree, you probably know about Redux. It's almost like if you had a Redux tree, but you had predefined actions with predefined reducers. And so you don't have to, it's almost as if you had a template for creating a Redux application, only you didn't have to write any of the reducers and you didn't have to write any of the actions. They're a bunch of generic reusable ones. Of course, that analogy falls apart as you start to dig in and say, well, but it does like asynchronous stuff and its side effects. Yeah, they're not reducers. Reactors are not reducers, but it's the same concept. In fact, on our website, in the README, I actually was pretty careful to try to put, as best as I could, analogies if you're coming from other technologies. So Redux in particular, there's the idea of like helpful mental models, and you go right to the README and it says, coming from Redux, it's kind of like this, which is, pre-built reducers and actions, and then explains why, but that's not totally the case because it's asynchronous and has side effects and blah, blah, blah. I have another one for publish subscribe. So if you're familiar with PubSub, it's just like PubSub except this, and as the community starts to dig into this more and says like, I don't get this part, or I only ever have done jQuery, explain this. Like, okay, well, we'll write something and we'll explain it. So, yeah, it's a good question though. Anybody else? What's up?
Nobody doesn't have any other questions. Can you bring up the references, the links again?
Oh, sure, yeah.
Okay, thank you.
All right. Very cool. Oh, and all the repos have the links to the other repos on them too. So as long as you get to one, you can navigate around.
What is your company?
developing this technology.
So this is what's great about this is
Sourcing it.
it's literally our product. The difference is our competitive advantage is we have a very specific data set. And that's really
What is your data?